All right, this is an illustration of the Tengri 137 magic square calculations. I'm basically going to break it down for you a bit and show you how you can build your own magic squares that would, even stump the smartest ET. I don't mean to take away from the interesting work everybody had done with the puzzle. It was fun to review, but I just wanted to show people the trick behind the magic square piece. Um, so I'll leave this spreadsheet up. I'll leave a link to it if anybody wants to sort of mess around with it. Um, so in the first example, I just want to illustrate the the sort of key behind the squares. You just got to make sure that, like Sudoku or that they are sort of unique in the way that they're created. So let's just do 1, 2, 3, 4, and then be 1, 2, 3, 4. Now this is a really basic sort of square. Just to, like I said, just to illustrate um, the reason for the uniqueness. Okay, so if you add that up, and I'm going to build off this, and I'll build a square just like the one shown in the Tengri puzzle. But I wanted to show you this first. See? Now, logically, yeah. So 1, 2, 3, 4. Add those up, you get 10. And of course, the same way here, same way here, same way here. Okay, but with the Tengri stuff, it's they don't have just 4 numbers. They have 16. So in order for me to do that, what I need to do is create a second set. So let's just do 1, 2, 3, 4, or 4. No, is it 1? So what's like? You can't. Oh, actually, hold on. Let me do this way. 4, 3, 2, 1. 1, 2, 3, 4, and then one. Sorry, 1, 2, 3, 4. I'm sorry. I'm just thinking sideways here. 1, 2, 3, 4. So now we have another unique square. I just turn this one on its side, and what I'm going to do is I'm going to take the number from here and the number from here and combine them to get another set of numbers. So it would be like 1, 1, 4, right? And then we'd have 2, 2, and then 3, 1, and then 4, 3. And I'll fast forward this so you don't have to watch me go through this whole thing. But I'm just sort of showing you so you understand what I'm doing here. I'm just getting a unique set of numbers. 2, 4, 2, 4, 3, 1, 1, 2, 4, and 3, 2. So now if I add these up, I should get another another square. Okay, so this is our sort of framework right here for rebuilding the Tengri stuff. So what I'm going to do to sort of help with generating new ones is I'm going to copy all of these numbers so that we have a reference and a simple calculation to do it. So let's sort this range, and now I'm going to just show you something interesting about the range. Now these numbers are important here. You'll notice there's sevens, 7, 7. So I'm going to mess with those numbers. So let me just repeat or recreate that formula. So this is 1 plus this, and that's really all it is, going all the way down. Right, so we got those. Okay, now the next step is to sort of recreate this square, but using these numbers as a reference. So, and I'll fast forward it so you don't have to watch me go through this, but I'll show you the first row. I basically got to do the same thing for each row. So this one's going to be 14, so 14 is here. This one's going to be 22 and 31, 43. Okay, and then I just do the same thing for the next 3 rows. And through the power of video, I'll fast forward this so you don't have to watch it. Okay, so now we've recreated this up here, and of course if I just do the calculations again, I'll get the 110. So now what I have here is this magic square that now we can now play with by changing these numbers up here. Now the ones you should kind of focus on are these 4 values here. As they change, so if I change this, I'm sorry, it's this, and this is what you can change. So from here, say I do 23, 7, 3. Sure. They don't have to be primes. I'm used to using primes. You'll notice that all these numbers are changing, and so is the value of all the magic squares. Now, if you follow along, it's just the uniqueness of each one of these values using this simple formula here. I mean, I could change these to 1, you know, and I'm still going to get a magic square here. Now, I guess really what Tengri 137 did was mess with the numbers enough so that he was able to get 666 for all of them. So let's do a 777. Let's see if we can go 17. Let's do 150. 155. Oh, you know what? I'm never going to get it this way. These are all even. So you kind of play with these numbers a bit until you get an odd, like that. So you have an odd number. 60, 61, 162. There you go. So we have our own sort of 777 magic square. Now that's one square. The other one had multiple squares. I don't recall how many there were, maybe 6, 8 of them. But that's just another trick using the same square. And the way that you can do that is essentially whatever you add to this one, you add the opposite to this one. Then you add to this one, add the opposite to this one of the same number. I'll show you how that works. So we'll just take number 2 because I'll need that. And I'll say 2 times this value times -1. So we get -4, and we'll do this times -1. I'm only doing this so I don't have to do it manually for the square. Oh, sorry. And then again, it's this equals this times -1, and then these again, and you'll get this kind of flip-flop. Like this, -4, 4, 4, 4. Okay, and then what you do is you take this value you add this value. And we want to keep so we have 161, then we just kind of paste this all down the row. We get an entirely different set of numbers. But because the math is pretty straightforward, you see, I'm taking 4 away from this one, but then I'm just replacing it on top of this one. And that's why you're getting this, the same number again. If you look at the Odins triple horn puzzle and take one of the squares and then you take another square and the difference between the numbers, it's the same thing. He's just, you know, doing the math. So you can do this. So let's do 4, 8. See how they're all different numbers. They all come out to the same value. So that's it. Just thought you would be interested in seeing how the square was built. Thanks.